So some future directions that I think we are looking at, or we sort of at least are exploring, there are 2 or 3 I'll briefly mention. So the first one is social network analysis. So we started with this. There are some issues I'll say, but this is one interesting direction, right? So this is, let's say this is a sort of Twitter graph. Of course this is directed in that case, but here it is undirected, and there is this person in the middle, right? And maybe all these people tweet about various topics, and depending on your interest and what they tweet about, you also tweet about something, right? And different people follow each other, right? So this is sort of the snapshot at one particular time. Now maybe there is a new person which joins Twitter, and all this person start following this new person. Now the question is, and all these people tweet about something, right? So all this information is given to you, right? You can just extract it from Twitter, and now you want to build a recommendation system where you want to say that whether this person is going to follow this new person or not, right? Whether you would recommend this person as someone potentially that they should follow or not, right? So this is the question that you want to answer. Now you can model it using Markov logic, right? You can think of all these rules where you have the rules saying that if the topics of tweets match, then they are likely to follow, right? Similarly, more number of friends really follow this new person, then I am likely to follow, right? So you can again try various different rules and see how well it does, right? And basically build a prediction model. But the problem that we ran into was basically scalability, right? I mean, if you are really working, we had a snapshot of Twitter, I think from 2010 or 11, that's really huge data, right? So we are trying to figure out how exactly to sort of counter that problem, especially for that size of problem, right? I mean, simply grounding the whole network may not work. Other is that there is this dynamic aspect here, right? There is this notion of time, right? Of course, that's another variable, but this really follows linearly, right? So how do you really capture that? So there was some work that was published last year. Yeah.
You have Twitter.
Yeah.
And we are all here, we're following each other.
Yeah. Yeah.
How on earth would something happening in California with people who don't know each other, don't follow each other, know these things,
yes,
how can affect us?
Yes.
And so their distance in the network should matter.
Yes, yes, yes.
But the basic formulation doesn't.
Right. Right. So it does in the sense that if deterministically doesn't affect, it prunes them away. But deterministically, it's very hard to say, right? Yeah. The effect really propagates. And
but the propagation dies. That's the
yes. Yes.
So if there are limit, that's if you remember sometime back I came to you, we discussed the same thing.
Right.
Can there be a limit beyond which you don't need to propagate?
Right.
In Bayesian network, for example,
can there be an outer bound?
Deseparation lets you sort of say that this stuff is so far away that it's not going to touch you.
But that is also deterministic, right? So it's equivalent is the separation, disconnected. But beyond that, I think there has been some work that people have done. There was,
for example, say using something, I do some kind of an EM type of thing. That I do a little bit inference on this part. Then I say, okay, let's assume that the unknown things on the boundary are, you replace them by the map evidence.
Right.
And then you separate them. You're done. Because that will not affect the other one later. If the map is high enough. I mean, if that probability margin is high enough.
Yeah. So I think there have been some attempts, but I don't remember anything which explicitly tackles this problem in a very good fashion. So that's actually where
parallel belief propagation has a problem with convergence, right? In a general
belief propagation, you mean?
Yeah, if you do everything in parallel, convergence may not be as good.
Even otherwise, actually, even any other form also, even if it is not parallel, I think, right? So there is no guarantee.
No, parallel belief propagation does not necessarily. It slows down, right? Unless you exchange data across parts of the network.
Yes. Oh, I see. In that sense, yes, sure.
Yeah. So, but in some sense, isn't there some idea that things happening so far apart?
Right. So I think the issue is that
propagate slowly.
Right. So issue is that, right. So at least in social network example, right. If you think about this 6 degrees of separation, they are not that far. Right, at least in a symmetric network, right? So that is one question, right? How far do you go? Because really the fan out is very, very high, right? So then I don't think there are very good
separation is because of your small world power law
characteristics. Yes.
And then the influence is not just the length, but it's also the
Yes,
the,
yes.
the width of that pipe. Because
Right, right.
If that pipe
Yeah.
has so many
Yes.
things going on,
Yes,
the
yes,
probability
absolutely.
of your propagating
Absolutely.
is much less than if
Absolutely.
it's a pipe just between two close friends. Right?
Absolutely, absolutely. But I think there hasn't been a very good solution to that problem, at least which is well founded. Right? I mean, of course, for a particular problem, you may try and know.
Right, you can do empirically engineering solutions.
Yes,
can
yes,
all be
yes.
there.
Yeah, engineering solution can be there. Yes, I think for a specific problem, definitely engineering solutions can be there.
But theoretically, you don't.
Yeah, so I think there have been attempts that people have looked at, but I don't think there is something which is very prominent and which stands out. There are, I think there are sort of variational method, but that's different, right? I mean, that will, yeah, I think this is more
That's
about.
still approximate inference.
Yeah, so that's different. Yeah. So one idea that I have, I think there is a lot more work to be done on that, is that if you could really cluster other nodes together, saying that their effect on me is exactly the same. So you could cluster the nodes approximately in these clusters which behave in exactly the same way, then potentially you could solve this problem, I think. Right, where you don't throw them away, what you're saying is that the effect is similar and effect is weak.
Yeah.
Right, so someone influencing me who is sitting in California, whether it's Anna or Bob, doesn't really matter. Right, I will just create one blob for them and then I'll just.
That is essentially making it statistical.
Yes.
Yeah, it's like replacing a gas by the. You're not dealing with every atom, but you're dealing
Exactly.
with the property.
Exactly.
So
Exactly.
this is
Exactly.
where the benefit will be his view about clustering, that the sensitivity of the graph will get reduced if you do the bit of clustering.
Right, and then you
I
can.
think because all the relationship between physics and this.
Oh
These
yeah,
sound
that's
gaps
yeah.
there.
No, there is very interesting. Although, so that's actually very interesting direction. I don't think people have looked at it, but the only issue is that most of the problem people have looked at is still finite,
Yeah.
right? But if you worry about Twitter or Facebook, we are reaching the limit of infinity,
Yeah, yeah.
and then I think lot of
Some
stuff.
statistical mechanics that-
Exactly, right? So there in the limit, everything can infinity makes things simpler, right? Because you can actually make some assumptions about tail events happening and not
Integrate things
happening.
out.
Exactly, right? So that's actually another sort of active side, right? So we had one paper where we talked about Markov in infinite domains, but that was, I think, still a little bit theoretical, where what we showed was that if you have finite fan out, then you can define a valid distribution. So as long as I know that every node has sort of finite neighbors, and local distributions are well defined, then you have sort of this phenomena where you can take limits in the infinity. But I think still a lot of open questions are there.